writing ratios, solving proportions, and using ratios to model geometric principles, okay, which sounds harder than it is. All right, so let's talk about a ratio. A ratio is just two or more numbers compared by division. And you can write them three different ways. You can write it as a fraction, which is the way we normally see it, right? A ratio is just a fraction. You can write it with a colon, or you can write it with the word 2. So basically, if you have it either of these two ways, usually you just rewrite it this way. The most famous ratio, the one we've been working with over and over and over, is slope. Slope is comparing the rise of a line over the run of a line. We're comparing two numbers by division, so it's just a ratio. Like, for instance, to get from the rise from -1 up to 3 is up 4, and then over from -2 to 4 over 6. So the ratio, or the slope of that line, is 2 over 3, right? Ratio is just comparing by division. Oh, I forgot to give you your targets. Right, so here are your targets for the chapter. All right, so if we put this in terms of geometry, a lot of times you'll work with figures that have a ratio of their angles, of their sides, between two figures. Okay? So if I had this problem, the ratio of the side lengths of this rectangle is 3 to 7 to 3 to 7. Okay? That's the ratio of their sides. So even if this rectangle was 30 to 70 to 30 to 70, you always reduce fractions to lowest terms. So if I had 30 to 70 to 30 to 70, what would that reduce to? 3 to 7 to 3 to 7, right? Yeah, yeah. Or give me another dimensions of that rectangle. What else could it be if we're going to keep that 3 to 7 to 3 to 7? Could also be what? 9 and 21, right? 9, 21, 9, 21. Because what did if I reduce this, what can I divide it by? 3. And if I reduce it, what do I get? 3, 7, 3, 7. Give me one more. What other rectangle would have that as a ratio? Good. 24 and 56. 24 to 56 to 24 to 56. Okay? That would have the sides would have the same ratio, because if I reduce this, if I divided all of them by 8, what would I get? 3, 7 to 3, 7, right? Okay? So all these rectangles, even though they're different sizes, right? So if I was going to fill up a rectangle full of gold for you, which one would you rather have filled up with gold? They're the same ratio, but are they different sizes? Yeah. So which one would you rather have filled up with gold? This one, right? Because it's bigger. Okay? So they all have the same proportion. They're all the same. The side and the top relate to each other the same way, but this one's bigger than that one. Okay? All right. So in this example, the ratio of the angle measures of a triangle is 1 to 6 to 13. Okay? So if I add this angle to this angle to this angle, I should get what? If I add all three of those angles together, what do I get? 180, right? So could the measures of the angles be 1 degree, 6 degrees, and 13 degrees? Does 1 plus 6 plus 13 equal 180? No. So it's 1 times some number, 6 times some number, 13 times some number. Just like we did here. We took 3 times 3, 7 times 3, 3 times 3, 7 times 3. 3 times 10, 7 times 10, right? We used some number to change the ratio to fit the proportion. Okay? So if we know they equal 180, how could I set that up as an equation? Anybody got a guess? Let's say the number that we multiply by is 2. That would be 1 times 2, 6 times 2, and 13 times 2. So I get 2, 12, and 26. Is that the number? Okay, then let's try 3. If I put 3's in there, I get 3, 18, and 39. Is that the number? Does that equal 180? No. Do we want to keep going? Do we want to try 4 and 5 and 6 and 7 and 8 and 9? Like, that just seems like it would take a long time. Right. If I set up an equation, and since I don't know what that number is, I'm going to call it x. But I know that if I add all three of these angles together, not 3x, 6x. If I add all three of these numbers or angles together, I get 180. Okay? So rather than keep plugging in numbers and numbers and numbers and trying to find it, I'm going to solve for it. Okay? So 1x plus 6x plus 13x, that's 7 plus 13, 20. So I get 20x equals 180. Divide by 20, and I get x is 90. 9. Sorry, 9. X is 9. So that means I think the number that should go here is 9. So the first angle, angle 1, should be 1 times 9, which is 9 degrees. Angle 2 should be 54, right? Because 6 times 9 is 54. And 13 times 9 is, let's see, 90, 117. Okay, does that work? Is 9 plus 54 plus 117 180? Yeah. So that's how I figured out what the angles would be. Does that make sense? Yeah. All right, so take a second and do the blue one here. So it's a right isosceles. If I gave you the ratio of the sides, would it be equal to 180? No. Well, yeah, could if it were, what would the ratio look like if it was side, side, side? If the sides were all equal, they'd all be the same, right? If it's equilateral. But if I gave you the ratio of the sides, you wouldn't set it equal to 180 because that's for angles. What would you set it equal to? Not a number, but what dimension? Starts with a P. Perimeter. Yeah. You'd set the ratio multiplied by x equal to the perimeter. And that's how you'd find it, right? Because sides aren't equal to the 180. That's angles. Sides are equal to the perimeter. Yeah, 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 yeah. Is that what you were going to? Yeah. You do 2x. Exactly. Exactly. All right? All right. Now, let's go one step farther. When two ratios are equal to each other, we call that a proportion. Okay? That just means that, like, if I say at Handel's Ice Cream, for every one sundae they sell 5 ice cream cones. Okay? So to make a proportion, I want to write a ratio that's equal to that. So let's say I said they sold 10 sundaes. How many ice cream cones did they sell? 50, right? Because 1/5 and 10/50 are equal ratios, right? So that's what we call a proportion, when we set two ratios that are equal to each other. Well, if I told you the 1 to 5, like 1 sundae to 5 ice cream cones, and I told you the 50 ice cream cones, then you could work backwards and figure out the 10. Or if I told you the 10, you could work backwards and figure out the 50. Okay? All right, and then I've never heard these two words anywhere other than the OGT. So if you would, remember these two words for like 53 more days, and then you're certainly welcome to forget them, because I seriously in my whole life never heard these two words again. But the product of these diagonal two numbers, A and D, is called the extremes, the answer, the product. And the product of B and C is called the means. So the means, the product of the means equals the product of the extremes, right? Cross products, you guys all know that, right? From 6th grade, 7th grade. Okay? And like I said, those words, I don't ever hear them called that, except I've seen those words on the OGT once in a while. So if you would, remember it for 50 whatever more days and then forget it. Actually, we're not even 50 anymore. It's getting closer. Well, for some of you that are freshmen, you have to remember it for 360 plus 15 more days. All right. So, but basically what it means is cross products are equal, which, like you said, you've done it a whole bunch of times before. So if cross products are equal, that means that 8 times x is equal to 3 times 56. Right? So I solve it by dividing by 8, and I get x is equal to 21. Okay? All right, can you solve this one? Try this one. Cross products, and remember, you're not multiplying 2 times just x. You're multiplying 2 times this whole equation. So it's 2 times x plus 7 equals 5 times x. Right. You have to distribute. Good job. Okay? So it's going to be 2x plus 14 equals 5x. And then you subtract 2x and you get 14 equals 3x. Divide by 3 and you get x is equal to 4 2/3. I tell you, a very, very common mistake is to just take the 2 times the x and not multiply 2 times both. But got that. So this is the cross products. This is the means and extremes. Can you rearrange this expression to be a ratio so that it's A to B, which looks like this, right, equals, and numbers there. Okay? So if I want to rearrange this so that B is on the bottom, what do you think I do here? Wouldn't I divide by B? Right? And that would cancel it from there, and I would leave it there. So I'd have 14A over B equals 35, because I divided both sides by B. So I left the B on this side, because 14A divided by B just becomes 14A divided by B. But the B on top and the B on bottom here cancel. So all I have left on this side is 35. Okay? Now, I almost have A over B. What's coming up the works there? The 14. How do I get rid of 14 times A? How do I get rid of the 14? It's right. It's multiplying, so to undo it, I divide. So I divide by 14 on both sides. Because remember, as in an equation, as long as you do the same thing to both sides, you can do whatever you want. So the 14s cancel, And all I'm left with on this side is A over B. And what I have on this side is 35 over 14. No, you want a ratio. But you can reduce it. What goes into 35 and 14? 7. So that's 5 over 2, right? So A over B equals 5 over 2. So if they give you this expression and they want to know what the ratio is, you can rearrange it into the ratio. Yes. Uh-huh. You divide by 9. Yeah. Yeah. Yep. Oh, no, equals, yeah, so it would be 4 over 3, not 3 over 4, right? Because when you divide by 9, the number is bigger on top. So you'd have 12 over 9. Both of those are divisible by 3, so you get 4 over 3. Yeah. Okay? Try this one real quick. Make sure you know what you're doing.